All right, let's go ahead and get started for the day, or for this video actually. We are going to discuss loops with chapter 5, and then we're going to go in and work on one of your assignments to demonstrate nested loops. So we probably won't cover nested loops on the PowerPoint. So some of the main things that we're going to be getting into are loops, general loops, the different kinds of loops there are, and the different increment and decrement operators for working with loops. And loops are a very common thing in programming, almost as common as if statements. If statements are more common than looping. However, looping is pretty much what gives a machine its intelligence, is to be able to repeat. And the faster it is, the faster it's able to repeat, the more intelligence your computer you can have, the more complex problems that it can solve. So that's done by, a lot of that is by keeping a running total. We call those accumulators. So we'll be talking about an accumulator, or also counters is a form of an accumulator. And then we'll probably get into one of your assignments to demonstrate nested loops. And then, of course, some of the other stuff in the PowerPoints you're going to have to cover, because I want to have some time to have some fun and get some code written. And what we're going to do is we're going to start with a while loop. So this is another control structure, just like you learned with your if statements. So actually it behaves the same way. All a while cares about is yes or no for repetition. And remember, you don't put your semicolon at the end of the while statement or of any control structure. So I'm going to go ahead and demonstrate a while loop. And you already know how the condition part works. The condition part is fairly easy, because it's just like the if statements. There's true or false. That's all it cares about. So let's go ahead and demonstrate that. And essentially, we'll demonstrate it with a counter. It's just going to be a variable that we set to 0, and then I'm going to say while 1, while true. So what that means is all that while is looking for, it only cares about true or false. It just cares about a 1 or a 0. And you can put the stupid true in there, which is basically just behind the scenes a 1, or false, but that's all a while statement cares about. So your relational operators, less than, greater than, they all work with true or false, just like you learned in an if statement. And in fact, logical operators work with that true and false too. So that means that everything you learn to learn about controlling if statements directly applies to controlling a loop. It's the same thing. The only difference is a loop looks at that condition to decide whether to repeat or not. And an if statement looks at that condition to decide whether to complete one region of code versus another region of code, making a decision. So what we're going to want to do here is, I've just created a really bad loop. And the reason being is because it has no end in sight. That means that the user has to force quit the application. And that while 1 means it's automatically, by definition, a runaway loop. Unless you have something in here where you ask the user to enter, and then you say something like break or return, and then that'll take you out of the loop. And this is the way most games used to be developed. They would just have a loop in there that just went until the user escaped from the game. But let's just demonstrate what this does. And I'm going to set the breakpoint, and basically we're saying while true, meaning, hey, This is always going to be true. And we're going to look at the repetition. Okay. So the while is looking at the one, seeing it's true, and it just continues going over and completing the same. So anything that you have between this brace and the closing brace will be repeated over and over and over and over and over and over again until you break the loop. So here it is right here, and this is what I call, I'm going to remove the breakpoint and hit continue, which means it'll just continue running the program. And we see that, you know, if you can see that output, we've created a runaway loop. Now, to force quit this, you can hit the stop sign up there, or you can do the Control Z or Control C, excuse me, Control C to force quit the program. So usually when you have a loop, you know, you need to have some way. The loop needs to come out. It can't be a runaway loop. Now this is 0. That means that the loop will not run at all, and that would be when the loop or the condition has a false statement. So you see it just skipped over it and just totally went away. So what happens when that happens is you'll see here, I'm going to do step over. It's going to evaluate, say, hey, the condition's false. Then the runtime skips over the whole thing and goes down to the next lines of code underneath the control structure. So then we have, you know, we get into like counters and stuff like that. Let's go back to the PowerPoint. Okay, so the statements are what is repeated inside the loop. And an iteration we call an execution of the loop body. An iteration means that this code that's in here, one full completion of the code that's inside the body is called an iteration. So that's basically how many times your loop runs. Now, if we do something like this, while counter is less than 5, you get into some of these issues here where you don't know kind of how many times the loop will run, and we call those fence posts, or off by 1 errors. And since it's 0, it starts at 0, we're going to less than 5. That means that, you know, hey, oh, you say less than 5, it should only run 4 times. But actually we're starting at 0, so maybe it'll run 5 times. 0, okay, well, in any case, get it, you know, if you're wondering about those off by 1 errors, you know, just put it in the compiler and test it out and see what happens. And then you'll start being able to visualize it in your head when you get that kind of test question. Okay, so what I'm going to do here is I'm going to just output counter. I guess if I can not mess things up. Okay, and then what we'll do is we will know each time through the loop what counter is at. And when the loop is done running, we know how many times we'll know how many times the loop is run. Okay, so I'm going to go ahead and run this. And we'll set counter to 0. Say while counter is less than 5. Well, counter is 0. If we pull it up, counter is 0 right now. We output counter. Counter is still 0. Uh-oh, what did we just cause? This is what we call runaway loop. Because counter is never going to be more than 0 in this loop. So what I got to do now is, if I want this loop to run a specific set of sizes, I get to use an increment operator. And we'll get into that, but with the PowerPoint. But basically, counter plus plus is the same thing as counter is equal to counter plus 1. So increment operators at plus plus. We also have a minus minus that decreases it by 1, but it's basically saying take counter and add 1 to it. So take counter, assign it to the previous value of counter or the current value of counter, adding 1. So that will, basically these two lines are the same, but as a programmer we prefer this because it's simpler and we all know what it means, because counters are a common thing that we have to do all the time. Okay, now we don't have a runaway loop. Let's look at it. Okay, while counter is less than 5, counter is 0. We output counter. Counter goes up by 1. Come back, counter is now 1. Output counter. Counter keeps going. Counter is now up to 3. Counter is now up to 4. Now it's going to increment one more time here. Now counter is 5. I go back up here and I say counter is 5. Well, 5 is no longer less than 5 because that fails. So that fails and it comes out of the loop. So we see that the values of counter go from 0, 1, 2, 3, 4, but we know also that the loop ran 5 times. And this is actually how you want to do counters. You don't ever want to go starting a counter at 1. Do not start a counter at 1. And the reason being is because we use counters to access arrays which are 0 based, and you'll learn more about that when we get to arrays. But never start a counter at 1. Always start it at 0 and go less than the number of iterations you want. So you start it, if I want 10 iterations, I'm going to start my counter at 0 and I'm going to go to less than 10. Do not do this. 1 less than 10. Well, that's going to not work because 9 is how many times this would run. If you did less than equal to 10, now it would run 10 times. However, only people that don't know what they're doing program this way. So always start a counter at 0 and go to less than 10. And then that'll always give you, as long as you started at 0 and you're going to less than, then you know that's going to run 10 times. And the reason this is, and I'll say it again, is because arrays are 0 based. And in fact, you know, everything is 0 based. The first thing is not the number 1. Number 1 is actually 2. 0 is the number 1. When you're actually modeling the real world, you'll get a better understanding of what I'm talking about. Okay, so that takes us back into a little bit of PowerPoint and the while conditions and iterations and kind of how that works. Now we get into an example. We just kind of did this one. So we're going to move along. Okay, so they talk about a while loop being a pre-test loop, and then you have a post-test loop. And the difference is you could have a while or you could have what we call a do while. The while pre-test, because your runtime goes from the top and works down. So that means that the while has to be passed before this code can be completed. You can do a do while, meaning that the code inside is completed and then the condition is tested for repetition. If you can, do not ever use a do while unless it's purposeful. Do whiles cause more problems than they solve. Get used to thinking in the while mode. Okay, and in fact, I would say do whiles and whiles aren't the best loops to use at all. I would actually use a for loop. And the reason being is because we have several things that we have to deal with. We have initialization of counter. We have increment of counter. And then we have the condition. That's usually the 3 things that we have to have for any kind of looping to be able to happen. We need to keep track of how many times we're looping. we need to have a condition that looks at that how many times we've looped and made a decision on whether we need to continue repetition or iteration. And that's with the for loop. Before we get into the for loop, let's catch up on PowerPoints here real quick, and then I also want to make sure that we have time to go in and have some fun. So let's talk about the increment and the decrement operators. So we talked about it already. So I showed you the postfix mode example. Y++ or counter ++. You could do another kind of counter that behaves a little bit differently. It's ++ Y. Now what happens here is if you put the ++ before the operator, then that means that Y is going to be iterated before it's assigned to X. So that means that this happens first, because if you look at the operation, the order of precedence of operators, a prefixed operation has higher precedence. So the ++ Y is going to happen first, and then it's assigned to X. That's with the precondition. Now, a post condition works differently in the fact that here Y is going to be assigned to X first, and then Y is going to be added to Y. So I don't really write code like this. I just put a ++. I always use the postfix, and I put it on its own line of code, so it doesn't really matter. But just know that when you're using the postfix and the prefix, those things have direct relations with your operator precedence and associativity chart on how they behave within a single line of code. So just know that Y is actually assigned to X first, and then Y is iterated by 1. And that's your postfix assignment. If it was prefixed, the Y would be done first, then assigned to X. And so that's definitely going to change the value of X. Y will not be changed the value of Y. It's going to still increment it by 1 regardless of whether you do it prefix or postfix. Okay. We already talked about counters, letting the user control the loop. You guys can get into that one. The do while loop, we just talked about it. And let's get into the for loop. That's where I'm headed. This is the one I suggest you guys use most. This is the one I suggest you use always. The do while and the while loops are only intended for specific cases where they're needed. Any other mechanism that you need to do can be done with a for loop, and it's much more controlled environment. So the propensity for runaway loops is a lot less when you're working with for loops. But the three characteristics I described: increment, initialization of the counter, increment of the counter, condition. That's all three here in the for loop. So you got your initialization, you got your condition, and you have your counter update. That's the same thing as what I got over here. So the increment of the counter, that's your update. Condition, that's your test. Initialization, that's this guy right here. That needs to happen so your counter actually starts at a number that makes sense. So let's convert this to a for loop, and we no longer need counter because we're going to inject that into the for statement. So I'm going to say for, and I'm going to say integer counter is equal to 0. Now this is pretty interesting syntax. I'm going to put a semicolon in there. And then I'm going to put my condition. I'm going to say counter must be less than 5. And then here is my update. Counter ++. Okay, so one thing to kind of take note of, traditionally when we're doing a for loop, generically we don't use counter, we use I. and then we use j, and that's just part of tradition. So I'm going to, instead of counter, I'm going to call it I. Okay, we don't need the I++ anymore, because every time the for loop, it's going to iterate the plus plus. Then, and every time through the for loop, it checks the condition, then iterates, and beginning, it starts with I equals 0. So let's look at how this behaves. Okay, so we got I is equal to 0, and we're going to put I as less than 5 and I++. I hasn't been assigned to 0 until we do a step over here. Okay, now I has been assigned 0. We've checked the condition. I is less than 5, so we can actually do our output. So we output I. Then the for loop comes back and checks the condition again. Hey, is I still less than 5? Well, it doesn't check the condition until it iterates I, and then it looks at I and says, hey, I is 1. Is it still less than 5? Yes. So we run again. Then we check the condition again and iterate, and I is now 2, and it's still less than 5. Then we continue on until we have where the condition no longer passes, where I is now 5. So I is going to run one more time, and then when it comes out, it's going to fail and come out and be done. So we have our 0, 1, 2, 3, 4 there for that. I'm going to throw in a system pause in here just in case. All right. And that's a controlled loop. That's the best loops that you can write, is in just that exact manner. And of course, we're going to have fun with a nested loop here shortly, as soon as we get through some more of these PowerPoints. Let's see, we're 20 minutes in. We're doing okay. Okay, so let's do another 10 minutes through these PowerPoints. Keeping a running total. This is what we call an accumulator, and it may be for something like for like a total. And we could be using it. Yeah, it could be a running total for some particular value. So for that, we usually have a variable called sum. It's very important that you know you got to assign it to 0. But we could take another floating point. Oh, it needs to be 0.0. 0.0, guys. It's a floating point number, not an integer. Don't do it incorrectly. 0.0. Okay. Now, I think actually to do that properly, we've got to put F in front of it. Something like that. I believe we got to put F to do that properly. Yeah, now that's done properly. We're just saying that it's a floating point number, assigning it to 0.0. So that's how you do a floating point number literally. That's a literal floating point number of 0.0. Okay. Let's see. We are going to accumulate. So what I'm going to do here is I'm going to say that sum is equal to sum plus number. And let's make number be 5. Now, this could also be written as sum plus equals number. That's the slang, because this is a very common operation. So it's the same thing as this. I'm going to go with the slang because that's the better way to go, because you don't have to type as much. And everybody understands what that is. It's just the same thing as this. And that's another shortcut for accumulators, for, just for, so we don't have to type out as much. So now I've got an accumulator that every time the the for loop runs adds 5 to the sum. And it takes the previous value of sum and adds 5 to it. So let's look at how that behaves. Okay, we're going to go ahead and start out. I is 0. Sum, number is 5. Okay. Sum is now assigned. Since sum started at 0, we said 0 is equal to 0 plus 5. So now sum equals 5. Now we run this again. We go through the next iteration and we say sum is 5. So that's 5 equals 5 plus 5. So that's actually 5 plus 5 is 10. So sum is now going to have 10 in it. And see, it's just accumulating. It's just adding, it's taking its previous value and adding a new value. And that's why we call it an accumulator, is because it's accumulating it from its previous value. And sum will be all added up through there up to about well, it runs 4 times. So but what you could do is you could just, when the loop comes out, you could just do a cout of sum, and then you would know what the final sum of that accumulator is, which is 25. Which makes sense because the loop runs 5 times and we're adding 5 every time. Okay. Sentinels is another important thing. I'm just going to kind of differentiate this, but basically a sentinel is kind of like a flag of a value they can hold. And basically, in this case, we have the user enter in points earned, and until you enter in a -1 for points, when it looks at points and it's assigned to a -1, then the loop comes out of. So this is an example of a sentinel, just to keep entering data until the user enters a certain value to tell it to quit entering data. And that's what this while loop does. And I would at this point, what I would like you to do is probably on your own, take this code, copy and paste it in, and then I want you to put it in the debugger and step through. Let me demonstrate a little bit of that. Just so you know how to do it. Okay. All right. I'm going to put in the debugger. Okay, now this hasn't run yet. I can't put my points in yet until I do a step over and run the CN. So I'm going to do a step over. Now the CN is running, and now I can go up here and put my points in. So I'm going to put in 25. Okay, so points, we get points of 25. Then we add up a total. Then we say, hey, enter some more points. I'm going to do another step over so that this CN will run. Okay, now it's waiting for my input. Let's do 22. Okay, I entered 22 for points. Well, points is still not -1. So I'm going to continue to add up points to my total. And then I get to entering points again. Step over. Now I enter my points. Let's do -1 this time. And I step over. Points is now -1. The loop comes out. And we're done. Here's the thing about the debugger that you want to start working with is, or the reason why you want to start working with the debugger is because it will increase your knowledge and capability immensely. If you start learning to work with it, you're going to learn quicker, you're going to learn better, and you're also going to have a social life. All right. I think we are at least a half hour in. Let's go have some fun. And that I want to do nested loops as part of the exercise. That's why I chose the one, and I'm going to let you guys go ahead and turn this one in for your homework if you're watching this video. So we're going to use nested loops to solve a problem, and that a nested loop is a loop inside of a loop, and so you can have repetitions of repetitions. And that means that, let's do a nested loop. What we're going to do is we're going to do a common for loop. For int I equals 0, I is less than some value. And we're going to just say, count. And then we're going to do I++. Now this is my initial loop. And then when you have a nested loop, we usually call this J. And this is going to do some kind of count. And I'm just going to put in count because I don't know how many times it's going to run. But let's say that this outer loop runs 2 times and this inner loop runs 3 times. So for every time that I runs, J runs 3 times. So that means since I runs twice, J is going to run 6 times. Because for every time that I runs, this loop starts over and reruns another 3 times. Okay, now we're gonna go look at the assignment, and then I'm gonna take a small break and hit stop, and it'll be a brief flash for you guys, and we'll come back to it. All right, so the assignment that we're going to be doing here is the triangle display. To do a nested loops to display the triangle pattern. And this is just your typical row column type behavior that we're going to have. We're going to have more rows and columns, rows in specific columns than others. So this is something that a nested loop can do. Because we can use I to go through all of the rows, or we can use I to go through all the columns. And we can use J, if we use I to go through all the columns, we can use J to go through all the rows. So we're going to get into that as soon as we come back. Thank you. Okay, and we're back. What we're going to be working with is the triangle display. We're going to use I and J to represent the row and columns of your triangle. And what I like to do is I like to kind of just begin with something simple, and then I go from there into making it more complicated. And what I would like to do is, why don't we just print out rows and columns of pluses all the way out as a square first. Let's just do a square first. Let's print out a square of pluses. And I'm going to use I for the rows. We're going to use I for the rows to count up the rows. So we need 1, 2, 3, 4, 5, 6, 7 rows. Okay, and then how many columns do we need? Well, the biggest, largest one is 1, 2, 3, 4, 5, 6, 7 columns. So that's 7 rows and 7 columns. So I is going to run 7 times, and J is going to run 7 times at least. Just to get what we want right now, which is just a square of pluses. And don't forget, the rule. Start at 0 and go to less than the amount you want. And that way you will never have fence post issues. Off by 1 errors. If you start at 1 and you go to less than or equal to 7, you're screwing up things there's too many issues with fence posts, and you end up getting like a +2 or -2 instead of a +1, -1 to fix those fence post errors. So if you start at 1 and you go to less than or equal to 7, you don't have an off by 1 error anymore. You have an off by 2 error. And if you're doing any kind of algorithms, and you see somebody that starts off at 1 and goes to less than, and then they got all these -2, +2s, and to offset their off by 1 issues, it makes it more complex. And then, of course, you know that this person has never really actually been trained. So go to less than, or start at 0, less than the amount of iterations you want. And if you always do your loops that way, always start at 0 and go to less than the amount of iterations you want. You will reduce the amount of fence post errors, off by 1 errors you have, and that you have to also change the code or modify the code, your algorithm will, to deal with them. And as you get into algorithms and working with stuff a little bit more, you'll kind of know the off by 1 error intrinsically. It pops out all the time. So what I'm going to do is, for this one, I'm just going to do a cout asterisk here, now, or a plus here, and then I'm going to hit the semicolon. Now we actually don't want it here. We want it here because all our printing is going to be done here. And if this loop runs 7 times and this loop runs 7 times, then the full loop is going to run 7 times by 7 times, and we'll have a whole bunch of pluses. In fact, if we did a counter in here, it would be 7 times 7 would be the amount of times the loop runs. I think it's 49 or whatever. So this is going to output the first pluses just for the rows. Okay, and then every time we get done with 1 row, we want to do something such as putting out a line break, just so that we can have our rows and columns. And that we can do with the \n here. Okay, now let's just look at what's happening now here. All right, I'm going to set my breakpoint, and we're going to run it. Okay. Okay, so I is going to be 0. We're on the first run of I. Then we go into J. And J is going to start printing the first plus. Okay, it goes in and it goes to the next plus. It's going to print 7 of those. And you see they're going, oh, that's the wrong output. You see that they're going across the screen here. Okay, so we continue on. We output the pluses. We're going across the screen. Here's the pluses going across the screen. Then we come back. Okay, where's J now? J is at, well, it looks like it's not showing us J. That's fine. We can go down here and go to locals. And it looks like, oh yeah, J is going to stay at 0. That's fine, because, well, this is interesting. Oh! This is a very common error, guys. You will find this a lot. Look at what I did. I++. I++. That's why debugging is so important. That should be J++. Okay, so let's go into there and run this again. Now that we have it running correctly, I should stay at 0, and now J is going to iterate appropriately like it should. So we get up. We just created a runaway loop there, by the way. Okay, so J is going up to, and it's printing those pluses across the screen. You know, we're going to continue, and there's another one, another couple across the screen. Okay, and then once we get up to where J is 7, it's going to come out of this loop. It's going to come out of this loop because now J is 6. It's going to do one more time. Okay, it's come out of the loop. It's printed 7 pluses just like we want, the first row. Now this is key. Before it goes back and runs through and does another loop of I to do another row, it's going to output a new line. So we get our new line. You see my cursor is now changed to the next line. So now I loop runs again, which is just basically telling J to run another 7, to print out another 7 pluses. So I goes from 0 up to 1, and then the J thing runs all over again. And here we go, we're running all over again. Okay, and the last thing we do when we come out of this loop is we do another new line. Right? Then I comes in again, and now I is going up to 2 to do the next row. Okay, and then it continues to do that. So basically all I is doing is telling J to print a row of pluses. Another row of pluses. And so we don't really have to worry about I anymore. It's pretty much doing the job we want. Everything we need to worry about is going to be happening here with this J. Okay, I'm going to go ahead and hit continue here. I'm going to remove the breakpoint, hit continue so it finishes running. And then we see that we have our rows and columns. So now what I want to do is I want to tell J to quit printing at a certain spot. And you know what? As we are progressing, and this is kind of just something that I've noticed that we could do, is as we are progressing into outputting with these asterisks, let me get to our assignment. It looks like we have 1, 2, 3, 4, 5, 6, 7. It looks like we're only printing 1 here, but we're deciding not to print any more of the pluses. But on the next line, we decide that we're going to print 3, and then on the next one we do another 5. I think there's a typo here, so there should be, it should go 1 and then 2. It shouldn't do 1 and then 3, unless it's got, oh yeah, so it may have a special iterator. We'll get close with it anyways. So we basically need to tell it to stop printing after the first one, but that's only for when it's the first one and the last one. But we can also notice that as we increase to this line, I has incremented by 1. And here I has incremented by another 1. And how many rows is this? 1, 2, 3, 4, 5, 6, 7 rows. So how would we instruct it to not print any more stars on that particular line? On the first line, we only print 1 star. I'm wondering if we can't use math in some way. Or we could just tell it not to print. Or maybe we can use the value of J itself and I itself to decide whether or not to print the pluses. You know what I think? You know what I'm going to try is I'm going to try not printing the asterisk or the plus. Let's see. What would be a good way to solve this? I'm thinking that we have a value J, but it's kind of being a stinker. You know what? Maybe we can use an if statement. Or maybe we take the value of, you know what? Let's do this. Let's use a counter. Let's use a counter. And this counter is going to represent how many stars we're currently printing. And we're going to start it out at 1. And so what we'll do is we'll go for J each time. We're going to make that counter. And then every time we're in J, we're going to do a counter plus plus. Okay, now what that's going to do is it's going to regulate counter every time through the loop, which means when we're done with J, we got to do a counter equals 0. So let's just see what that gives us. Oh, okay, well, a never-ending loop. Guess what? I'm going on pause. I'm going to have some fun with this, and we'll come back and take you through it. You know what? I decided a better way of doing this, and I'm going to actually let you guys finish this one because we're coming up on the hour, and I don't want to take too much of your time messing with this. But here's where the direction we could go, and that would do a lot better than the manner I'm going. We would run J and only output J based on a function of I. So what we could do is we could say J is equal to something minus I, and that will be because I is representing the rows, but not only that, but the asterisks. So we could say something is J is less than something. We can use the actual we can use I and J and just subtract I from the current line number we're on. So we still need counter. But counter is going to maybe just give us our line number that we're on. And this will be kind of the direction that you can go. And I'm going to do a counter plus plus. And all it's keeping track of is where we're at. So we're going to say J is less than, so when J is 0, we're going to say J is less than I plus counter. Something like that. You know, let's just look at it and see how it behaves. Okay, so you see, wow, that's pretty close to what we want. However, we need it to go down now. Oh, well, you know what? Why don't we just do this? Why don't we... There we go. Is that what it would work? Oh, well, you got some things to figure out there. You can start playing around with this and decide on how many pluses that can be run based on where you're at with your I iteration. And that's the direction forward. And, you know, hey, yeah, I've done it 100 times, but this is also a good exercise for you guys to get into. What would you have to set I to? How many times would you have to run I? And how would you determine how many times to output this based on what particular row you're on? And here is the start for you to kind of get involved in and have some fun with. You may be using some minuses in here. You may be adding another for loop. You may come out and solve the problem a whole nother way. But this is kind of an example of how you would go about heading in that direction. Okay, guys, go ahead and finish that one up, and you can turn it in. Thank you. Bye.